My objective for this session is help you understand basic analytical functions that Netezza has. Now, what is your exposure to analytical functions before? Have you used any of the basic analytical functions we do?
Yeah, like in Oracle, we are using like pivot, rank, then partition by, top, and those kind of analytical functions.
Yes. So that's the same basic things we are looking at in Netezza. Before I go into analytical functions, the first thing we need to understand is aggregate functions. When I say aggregate functions, these comes to my mind: count, max, minimum, average, sum.
Yep.
One of the one of the examples we use aggregate function is to find out tables queue. If I log in here, when I say NZDS, it shows me list of data slices available. Since this is an emulator, I got only 2 disks here. What I'm doing is I'm entering into ngSQL to a test DB1 database. And I say select count star from.
I cannot see anything.
Yeah.
I mean, it's still showing me that yeah, basic. Yep. Now I can see that.
Okay. What I've done so far is I've just logged in. So I'm just connecting to test DB1 database. I just want to find out number of records in this customer underscore old. And it is select count star from. Is there any use table I got here? I'm just bumping up my M customer table. If I want to find out a count, I say that select count start from M customer. Count is one of the aggregate functions. But there is a concept called tables queue. When I say tables queue, right, it's a bad thing. First of all, it's a bad thing. Skew is nothing but improper distribution of data. When I say I have 2 data slices here, when I say I have 2 data slices, I need to check that whether I have data getting distributed equally to all these data slices or not. Now how do I check that? This is a query. Select data slice ID count of data slice ID from M customer group by data slice ID. What I am doing is, for every data slice ID, because data slice ID is one of the invisible columns, right? For every data slice ID, count the number of data slice IDs we have, but since I am using a count here, I am using a data slice ID in a group by class. This is the rest of the columns I need to put in a group. Look at two different notations of count star here. This count star will work on entire result set here. This count star will work on all the 500,000 records. But here the count star will work on group number 1 and group number 2. But the point I am trying to make here is, whenever we work on these aggregate functions, right, they return one row for each group. In this first example, the group is all the records. But in the second example, the group is based upon data slice ID. Doesn't matter. For each group, it has a capacity to return only one record, that is a top record. Or it has a capacity to return only one record. That's the same thing true with sum or average or minimum or a maximum. But in certain scenarios, we might need more than one. We might need top two for each group. For example, we came to this stage in career by writing so many exams. For example, we have so many entrance exams that we appeared in the process of this career. So if you go back and look at these 10th grade entrance exams or 10 plus 2 or graduation, what if I want to find out the top 2 students for this specific district? What if I want to find out bottom 2 students for this specific district? What if I want to compare this specific district with the rest of all the districts? One state with another state, right? What if I want to get top 3 students under female category? What if I want to find out top 3 students under rural category? Because it's unfair for me to compare students coming from rural sector with people living in cities. Because the amount of infrastructure, the infrastructure that people in cities have is different than people in rural areas. So if I want to such kind of grouping, I want to find out what are the top 3, bottom 4 or top 10, bottom 10. That's where we go for this analytical function. Analytical functions generate aggregates but can generate multiple rows for each group. Unlike aggregate functions, these analytical functions also works on groups only, but they can generate multiple rows. SQL analytical functions help answer questions such as regional sales levels as part of top sales, or what is my 12-week moving average, what are my top 3 stores in each region, questions like that. Any questions on this slide, Vidhu?
Nope. Nope.
So to understand these SQL analytical functions, yeah, that's in the next slide, but in this slide, we are putting it here that Netezza SQL analytical functions are divided into below categories. Reporting or window aggregate family, which helps us to compare values at different levels of aggregation. For example, region sales versus total sales. Lag and lead family. You can compare current row with one row by specifying offset. We have an examples coming on this. First and last family. Get me the first 20 guys and get me the last 20 guys. Tracking family. Row count family. A hypothetical set family. This is helping us to forecast. Inverse distribution functions. So these are the various categories SQL analytical functions have been classified. Before we understand these functions, it is important to understand the analytical functions terminology. The first one is how an analytical function queries are processed. So here I am talking about including analytical functions logic in an existing SQL. When I talk about my existing SQL, I have something like this. Select SID, SGender from customer, where customer ID equal to 20, probably count of quantity. I say that group by SID, SGender having count of quantity less than 100. This is my regular query. But if I am talking about including any rank or dense rank, these are the various functions here, right? How the query will get processed. If I don't have this, the way query gets processed is first the customer table will be accessed, then where clause is applied, right? Then group by will be coming into picture. Then from the given result set, having will be applied. So for example, when I do customer scan, I might get 1000 records. When I apply a where clause, I might get only 10 records, right? The result set. The result set is just nothing but output of a select query. It's slowly coming down from 1000 to let's say 100 records. Then you apply this having condition. Then you apply the group by, then you show the result. If I include an analytical function such as rank here, will there be any change in the order of precedence of this execution? At what point these analytical functions come into picture while executing a SQL statement is specified here. If there is a query which has analytical functions that I am executing, it processes all joins first, where clauses and having clauses, and then whatever is the output of these whatever the output of these operations, the result set is available to the analytical function. Then at the end, the order by clause is applied. For example, here I have order by SID decided. First joins, where clause, having, those kind of stuff is applied. Then whichever is the result set is available for analytical functions. At the last, the order by clause will be coming into picture. Another important terminology that we need to understand is a partition, the term called partition. Partition is nothing but before this result set available to the analytical function, or before analytical function takes this result set, I want to group my result set. Let's say there are 1000 rows survived these joins, where clauses and having clauses. Am I going to consider all 1000 records as a single input, or am I going to divide 1000 records into male or female group, or rural or cities, or state wise, whichever is the way I want to divide the partition. So that's the first important thing. Once I divide into partitions, for example, I have 1000 records that survived this. Let's say 100 records survived this. So now on 100 records, the analytical functions has to work. Now how I divided these 100 records? Male is one group, female is another group. Male might have 60 records, female might have 40 records. Now when I'm working on the queries, this is one partition to me and this is another partition. So this is the concept of partition. The next concept is window. Only when I am working on these partitions, I'll only consider male partition separately and female separately. But when I am working in male itself, I'm talking about 60 records, right? So for example, I say record 1, record 2, record 3, record 4, record 5, record 6. So if I just reduce this number to 6 and 4, when I am processing this record 1, what other records I will consider? So if I say the current plus 2 more, then the window is 3 records. When I say window is current row plus 1 back plus 1 front. So the window I am talking about is 3 rows. When I do some processing on this record 1, what do I consider? Record 1 plus record 2. When I work on this record 2, record 1 record in the past, the current record plus future record. When I work on this one, record 2 plus record 3 plus record 4. Something like you have a store. You have a store. You want to compare current month with the previous month. Let's say this is which month, March, right? you did $10,000 of a sales. Feb you did $8,000 of a sales. April you are forecasting 20,000. Now when I am calculating the business that I have done in February, I'll compare this February with one month back and 1 month forward. So then in that case, Jan, Feb, March is one window. Window, for our flexibility, we divide the partition further into windows. So you say that from 6,000 to 8,000, you got an improvement of so 25%, let's say. So when you compare with March, it is 20% down, 25% improvement over Jan, but 20% down over March. So what I'm saying is when I calculate the February sales, how best we did in February, we are comparing with 1 month back and 1 month forward. So then these three becomes my window. Similarly, when I do it to the record 3 plus record 4 plus record 5. Record 4 plus record 5 plus record 6. When I talk about record 6, there is nothing to compare, so it's only record 5 plus record 6. So in these 6 records of one partition, I got how many windows? 6 different windows. This is window 1, this is window 2, window 3, window 4, 5 and 6. Right? So the next important term to remember here is this record 1, record 2, record 3, whenever it is processing, it is called as a current row. Just for benefit of understanding the analytical functions, this record 1 is a current row. When this current row is in focus, record 1 plus record 2 is considered as window. When the current row of record 2 is in limelight, so record 1 plus 2 plus 3 is considered as window. So the three important terminologies to remember in analytical function is what is my partition. Within the partition, how I am dividing into various windows. What is the key focus is my current record. To help us understand this terminology, there is a master example here. This example, I'm creating a sales table, and in fact this example taken from Netezza manuals itself. So which has like city, the city belongs to a state is part of a region. It's like some store sales details against quarter one, what is the amount of sales they have done and what is their profit margin. For example, Atlanta city, which is in GA state under central region, quarter one, they have done this much of a business. Quarter two, quarter three, quarter four, this is how their business margin. Right? So let me create this table quickly through Agility Workbench. The table is created. When I say select count star from sales, we'll get approximately 21 records, 24 records. When I say select start from sales, I can see all those 24 records here. Right, so I have stores from different cities, Atlanta, Seattle, until New York. I have 1, 2, 3, 4, 5, 6, 6 different states. Each state has its own geographical conditions. Right. When I say select start from sales, order by amount, descending. So when I do that, LA is scoring high because it has done the highest number of business, in a quarter four, the profit margin 22. So this is just considering everything as a single partition, and I'm just saying order by amount. But is it a fair way of comparison? Is it a fair way of a comparison? Because in a quarter four, LA working conditions and probably the Atlanta working conditions are completely different. Both belongs to different regions, one for Southwest, other one for Central. But what I am interested here in is, I want to see what is the top one in Southwest and what is the top one in Northeast, what is the top one in Central or other regions accordingly. So let me get introduced to the first functionality called rank. So here is an example. Select star rank. This is a function over. I'm not saying any partition by class right now. So I'm saying that order by amount descending. I'm just trying to give a rank where region is northeast or region is central. So let me run this and show you how it comes. So why do I need to have these where clauses? Let me take the where clauses out. The basic uses of rank functionality is it orders the data by amount descending, and we are just getting a ranking here. 1, 2, 3, 4, 5, 6 is for 3 places because these 3 are matching. This is a basic usage of using a rank functionality. It's something like ranking students across country. Let's say these are the various students who appeared for entrance exam at a national level, and we have just ranked them, right? But this might not be fair because the study conditions of LA are different from study conditions in Atlanta. What I am interested in is, I'm not interested in a national ranking, I am interested in a state-wise ranking or region-wise ranking. In that case, what we have to do is select star rank over, you have to say partition by region, each partition order by amount descending, and you name it as a ranking from sales. When I compare with the previous one, I'm just adding a class here that partition by region. So you remember the order the query gets executed. First, any joins will be executed, then where clauses, then group by having, there is nothing here. So it fetches all the data from this sales, that is 24 records, and gives it as an input to this rank function. Now rank divides those 24 records based upon region as a partition. So 4 different partitions or 3 different partitions. Now against each partition, it orders the data by amount descending. Now if I run this, now I got the ranking. For central region, rank 1. For central region, these two are ranking equal. For northeast region, this is the first guy. For southwest region, this is the first guy. So instead of me giving ranking at entire national level, I give a ranks at individual region level. Now on the same line, there is some other command called dense rank. This is another analytical function. What did I miss here?
You forgot the from clause.
So it's same as a rank function, but it won't leave any gaps. So 1, 1, you're getting like 3 here, but it starts with 2 here. The concept here is just the partition by region is like I have like 1, 2, 3 different partitions, 4 different partitions. In each partition, it orders the data by amount descending, then applies the rank or dense rank functionality. Any questions till now, Vidhu?
Nope.
Let me explain you another important aggregate function called row underscore number. This guy will help me to even filter out duplicates and it helped me, and it's helped me solve the problem of lack of primary or unique key constraints. Now for that, what I am doing is I'm creating a marks table here. Hold on a second, let me check. Yeah, this is the best example. I'm creating a marks table here. Student ID, student percentage, insert load date. Basically, this is when I did load the records into the marks table. Since data warehouse is a time-driven system, we expect the last column to be the data load date. So that's the key here. Then I'm loading 4 records with yesterday date, saying that 501, 502, 3 and 4, their cumulative percentages are like this. So when I load this data like this, when I say select star, I should be able to see those 4 records like this. When I say order by SID, five zero one two three four. This is how this code in the exam. But today what I am doing is I am inserting another 4 records. Since Netezza recommends not to update, and it is a very good system when we do inserts, what do I do is I design a system in such a way that I just insert it. I don't update it anymore. So I'm inserting another 4 records for 501 guy, 502, 3 and 4. Even though I set here primary key, it's still allowing me to insert duplicate records. Now when I say the same thing here, now against 501, you see 2 records, one with the previous insert date, one with the current insert date. Student average has increased from 20 to 99, but doesn't matter, but I'm still having the old record. Now let me insert for the tomorrow date, third date. So I have 3 records, right? Now out of this data, what I would like to pick up is I would like to pick up always the latest one. I would like to pick up always the latest one. For example, here if I insert another record, just for argument's sake, that insert into marks values 504, he got 89, current date plus 2. Right? Now when I say this, 501, so I always need to pick up the latest one. The latest one should be here based upon the order date. Let's say loaded date. 50 should be whichever is on 23rd. 504 also the same way, whichever is on the 24th. Now to do that, here is a function. I say that select star, give a row number over partition by SID. So take all 501s into one partition. In this partition, order by last date. So why I'm using this where clause here? Let's not do this. So let me run this. Let me just run this. when I just execute this, what I am giving is, I am considering all 501s as one partition, I am giving ranking. Then I am considering all 503s as one partition, I am giving ranking. So I say here that order by SID. This is pretty much like a rank, but we are saying the row number, right? So all 501s will have this 1, 2, 3. So look at the 501, you have 1, 2, 3, 4. Which one is the most important for me, most latest record for me? Whichever is a row ID 1. Row ID 1 is the latest record here, right? Now what I do here is, I'll just build this select statement on top of it. Say that just show me the latest records for me. Right? Even if I
Yep.
insert another record here. For example, 501's aggregate percentage 99, but he messed up in the latest exam. So his aggregate came to somewhere like 81. And when I run the same thing again, it should show always the latest one for me. So 501 got only 81. That does not mean that the old records removed. The old records are still there, right? So we'll talk about the old records to delete the old records. Before that, what I do is I'll just build a view on top of it. Same thing, I'll just build, instead of marks, I'll just say v underscore marks. Now when I say select star from v underscore marks, it's the same thing that queries marks table, but it's just a wrapper on top of it, which gets always the latest records for me. That's it. That's what we want to see, right?
Yep.
But the key is the load date has to be there. So that's the key for those tables wherever we want to implement this. Now if we have to delete the old records, I can create or replace a view where same thing, where we are saying that x equal to row equal to 1, we are saying that row not equal to 1. We are building another view here. So I just delete from marks where row ID is not equal to 1. That will clean up the records. But this needs to be done on occasionally. So 10 rows were deleted. So if I go back to the top and say that this one here should be able to see only the current data. But as you know, overnight the data will come in. So if I again insert another data here, so I can blindly believe on this view that this always gets me the latest data. That's what we are interested in. Like this, you can build these views. Right? Sometimes the records can be cumulative of change details only you put every day. So it depends upon your logic how you want to implement it. But this is one test case that helps me to solve the problem of lack of primary key enforcement. Right? So we just keep doing that data inserts, but while we are using these tables in the dashboards, Instead of using the base table, we can refer the views. Generally what happens is in other systems when we use views or when we use any analytical functions like this, you might lose the advantage of indexes. But here anyway you don't have indexes, it's safer to use them. So that's actually the another analytical function, row number. This is the one I was talking yesterday. Right. So another important one is lag and lead family. Lag and lead family. So to help us understand this, here I'm creating another small table. So this lag and lead family is like I was talking about here. To calculate the February sales, I'm going back one record, January. This is like a lag. Lead, I'm using the future one, lead. So how do these lag and lead work? Here is the example. Let me show that with an example. So I'm just picking up table here, sales underscore L. So in a 2011, under month 8, so the total sales like this. 9th month, 10th, 11th, 12th, and then 2012 came into picture. Yeah, let me repeat this here. So what I have done here is I have created a sales table, right? Now, when you look at this function here, I'm using the lag function. Before this lag function gets applied, once the result set from a sales underscore L that is presented, that's like how many records? 7 records. Those 7 records are partitioned by year. That means 5 records is one partition, 2 records is another partition. The 5 records, the cursor will first go to the current row. This is the current row. In this current row, when I am working on this amount, it is compared against one record back since I am using a lag. So this 1000, there is no previous month, so the percentage is null, right? So let me run it one more time. So whereas when I talk about a month 9, that is 900, it is compared against 1000, so the percentage increase is 10% down. So when I compare with 10, the percentage increase is compared against 900, so the increase I got is 22%. Here I am comparing with 1 month backward. in a partition here only for these records only. I can again say that here I can compare with 2 months back. Generally, when you look at our inflation calculations, the inflation of a current month is compared against exactly 52 weeks back, exactly a year back, right? The same thing they do is a lag functionality by comparing current month with or current week basically with 52 weeks back. Similarly, you can also use lead. Instead of comparing with the current month, it compares with the future month. So compared to the ninth month, this guy is 11% higher. So like this, you can keep comparing the results. So that's where we use this lead and lag functionality. So these are all the analytical functions I want to bring in here. The first one is rank, dense rank, row number, lag, and lead. Netezza itself says that they have more than 200 plus inbuilt analytical functions, and there is a way you can install those analytical functions packages on top of it, but that's beyond the scope of this course. If I show you, there is some setup I have how to install this Netezza setup. Hold on. You just in case you are interested in installing analytics. So there are some databases that come with those analytics, right? In the sense time series analytics and things like that. I'll share you these steps.
Okay.
So this is a directory you need to go and you need to run this installer. And these are the couple of links that talks about it, right? So these will bring in couple of databases. Yes, I want to install analytics package. Yes, I want to.
So in order to install this, we need to have the admin privileges, right? We need to go via admin
That is true. Admin
user.
can only install. This actually brings in those time series functions, these analytical functions that you can play on, right, on the various data sets. What this installation does is it brings up these databases, our database. So I've done this once, but so something like, but did not get explored much on this. See, if you look at other databases, the way they are positioning is Teradata and probably Exadata, it's a data warehouse systems. But Netezza is just staying one level ahead, saying that it's an analytical database. Now they moved even above that analytical database. Now they are saying it's a logical data warehouse. Like I said in yesterday's session, logical warehouse means it helps us to connect to various other unstructured environments through various connectors. The fluid query is one example.
Yep.
It just like staying ahead in the game. So even now Exadata comes up with so much of advancement, it says that it's best for analytics. Now what's next? The logical data warehouse. Move less, scan less, Probably the whole fundamental principle of these guys is move less, scan less. So that's where the fluid query comes into picture, where the query goes to data rather than data is coming to query.